Hey guys, so here is a video. Before we get started though, I want to go through the bags since this is our first video of the week and I make these bags for your convenience. And if I have to make them, I'm going to go ahead and talk about it first. So here in our bag, notice how that virtual world geography class starts at 10:24 and it's going to last until 10:45. So if you are ever having problems, if all of your grades aren't inputted, if you have any late assignments that you haven't completed yet, those submissions are already shut down and you have to log into Zoom for us to have a conversation before I am giving you permission to submit stuff. So it's all going to be taken care of through Zoom. Guys, you don't get after school tutorials because that's what that Zoom is for. So make sure that you are showing up to it, okay? Because if you miss it, then I'm assuming that maybe you just don't care, or if I don't see any activity on your side, then I'm like, I don't know what's going on. Is it that you just don't want to do the assignment because you don't care, or is it because you have like a technical problem? I don't know that here. So make sure you are, contacting me one way or the other. Once you see that grade start to go down, then you need to be logging into Zoom so we can have conversations and we could both be on the same page. I had kids today face to face and I showed them their grade book and what I saw, and they're like, oh, I thought I submitted it correctly. And so even with my face-to-face kids, we still need to be on the same page. So for you guys who are virtually and at home, you really need me making that effort, okay? To every other week or so, even if everything's going smoothly, just come check in with me and say you're good so that there's no issues, okay? Virtual learning only works if me and students are still actually communicating, because we still gotta be on the same page on things. Okay, I'm off of my soapbox. Here we have the week's lessons. Notice that on Friday we are taking another test, and it's going to be just like the last one, where you're going to be given a PowerPoint and you're going to be given like a problem, and then you have to explain your answer. So you really have to be paying attention, and you should not be waiting until Friday to finally watch all of the videos and go through all of the PowerPoints to finally get it. Okay, that's not, your grade is going to stink. And honestly, on my side, when I'm looking through some of these, it shows that you're not watching the videos. It shows that you're not really paying attention to the PowerPoints. So do a good job. All right, so today we are going to be focusing on plate tectonics. Tomorrow we are going to be looking at internal forces, like inside the earth, and how they are moving the tectonic plates and creating landforms. And then on Thursday, we're going to be looking at external forces like wind and water, things that are on the outside of Earth's crust, and how that's going to kind of play a role in some of the different landforms that we see. And then our test is Friday. Do not wait until Friday to come and ask me questions, okay? Let's go ahead and go back into Schoology and let's look at our materials. All right, so we are in this black folder. You already found it because you are here with us. And then we are doing the second item listed, September 8th, assignment plate tectonic layers of the earth and landforms. You are going to click here where it has a My Document. That's where you are going to click on so that you can start editing. Make sure that once you are finished editing, you come back here and you click Submit. All right, so this is what we are going to be working on here. That's just a screencast, I think. All right, so here we have our plate tectonics, and these all things, let me move this little video thingy, are all kind of impacting the other. So we start off with the core, and this core is going to show us like it is solid, it's made out of nickel and iron, and it is surrounded by the outer core. The outer core is going to be liquid. It's super, super hot, and it's going to be melting the mantle, okay? You don't need to write anything down. This is just us talking right now. The mantle is going to melt, and then it breaks up the crust. And so this is where our crust, the crust of the earth, starts to move. And that's where we end up with like volcanoes and some earthquakes. It's all because of that. So as all of this is happening, because it's moving all of the crust of the earth, that's what leads us here into the tectonic plates, where we have these like puzzle pieces. And if I move one puzzle piece, it's going to end up pushing all of the other puzzle pieces together, okay? So all of these puzzle pieces are now going to be like sumo wrestlers, and they go bam, and they're going to hit each other. And then that leads us to, like, especially right here, we have mountains, and that's going to lead us to big, huge, beautiful mountains or plateaus. And it's also going to create these divergent areas where we are pushing. Sometimes the forces on the inside pushes things away from each other. So what your test is going to look like, it's going to look like you getting a piece of land. Sorry, I am erasing. Is you getting a land. I don't know an easier way to make this go away. Is you getting a land form, and then you have to tell me, like, how was that created? What happened? Okay, but that's tomorrow's problem. So let's go to our next one. All right, so we are here, and this is what you are going to be working on. It's going to be how you need to define in your own words, okay? If you don't define it in your own words, then you're not really going to get credit. The whole point to taking notes is saying it in your own words so that when you go back later and you look at it, you don't have to like be like, what does that even mean? Okay. So make sure that you are looking at this and saying it in your own words. I am going to go back to the other slide, but you should probably stay on this one so that you could answer it. So if you're following along with us, you could go ahead and stay on this slide so that you are able to start typing. If you choose to do this on paper, that's fine. You could make like a chart on your paper, write down your definitions, and then you are going to take a picture of it and submit it to the slide. There is this video here. The guy talks really boring, so we're just going to, move on with life. So we're just going to skip on it. So let's go ahead and talk about these 4 layers of the earth. So we have the inner core. This inner core is going to be the center of the earth, and it's going to be a solid ball. So here in the center of the sphere of earth, we have this really hard ball. It's made out of metals, iron and nickel, and it is going to be the center of the earth. It is solid. It doesn't move. It stays right there. There's a theory that all of the pressure of the earth makes it into a solid ball. I don't know how true that is. I'm not a science teacher. So what you should be writing, and I'm trying to help you over here by marking it, is that it is the center of the earth and it's a solid ball. Let's go ahead and talk about the outer one. The outer layer is going to be, again, iron and nickel. And while that's important, that's not something I will really ask you about. You should probably write down that it is a hot liquid and that it is melted. So this melted hot liquid is going to kind of be going over this hard core, and it just kind of like sits on it and moves around, okay? The mantle is also going to be really, really hot, but it's not going to be as hot. So think about like sludge, like syrup, like molasses, and it's going to kind of sit on the outer, but it kind of just like moves, okay? And it's going to be moving as fast as your nail grows, okay? So it's kind of moving really slow, and it's there sitting on top of the outer one. Now, the crust is just like a pizza crust. On the outside, it's like really thick, and it's going to kind of differentiate from what's inside of the earth to what's out of the earth. And this is just going to be like Earth's surface would be the best way to kind of sum it up. It's the crust of the earth. It's Earth's surface. You are either on top of it or you're underneath it, okay? Let me erase all this stuff. So all of this kind of plays a role in our tectonic. There has to be an easier way to erase this. All of this is going to play a role in our tectonic plates moving across the crust of the earth, okay? And so let's go to our next one. You should have already listed this. And now let's watch this video, okay?
The idea that our planet's continents drift around the globe, periodically glomming together and breaking apart, is at least 200 years old. But most geologists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth's crust is broken up into fragments, and that those fragments, called tectonic plates, are moving. And these days we directly track that motion, with millimeter precision, from space. The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding.
Right, so that's one of the reasons why we were talking about the crust and the mantle was they just kind of talked about it right there, was how the mantle, comes up and then it starts to cool it again. And so it kind of breaks this and then it comes this way and it kind of cools again. So that idea that the heat really plays a significant role because it gets all hot and boiling and then it kind of oozes out and then it moves some of that plate tectonic. And then once it starts to cool down again, it comes back in, heats up, and then it happens again. Think of like when you're boiling water for ramen noodles, okay? And you have like every one of those heat bubbles that comes up, it's going to kind of break the surface of the water, and it kind of like the water is constantly moving because those heat bubbles are coming and constantly making it move. So the same thing is happening here with the mantle and with the core. And the surface of the earth is constantly moving because of that heat.
Tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. But the plates aren't just passively riding these currents around like a bunch of suitcases at the baggage claim. They can't be, because some of the plates are moving faster than the currents underneath them. For example, the Nazca Plate, a chunk of ocean crust off the west coast of South America, is cruising eastward at about 10 centimeters per year, while the mantle underneath it oozes along at just 5. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental land masses, the thinner of the two plates bends and slides under the other. As the edge of the sea floor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide. The bigger the sunken portion of the plate becomes, the harder it pulls and the faster.
I would personally just pause it right now and then answer that last question, what happens during a subduction? This is a perfect picture talking about how all of this stuff is zooming, and kind of think of two sumo wrestlers. Okay, we have like one that's like really small, and then we have one that's really thick, and then bam, who's going to win? Well, the skinny one goes under the earth and the big one's up here. So this is what's happening to subduction. A lot of times when subductions happen, lava is going to seep through. And then what happens when we have the lava coming out of the earth? volcano. So then we see a lot of volcanoes happening around subduction areas, but that's tomorrow's lesson. I'm going to go ahead and push play again. Hopefully.
After the remaining plate behind it moves. You can find where this is happening just by looking at Google Earth. The incredibly deep, narrow ocean trenches visible off the coasts of some continents and island chains mark the creases formed as ocean crust plunges downward, bending the edge of its neighbor in the process. What's more, these chunks of seafloor are actually helping to drive convection in the mantle beneath them. Sunken slabs of ocean crust block flowing rock from moving further sideways, forcing it to turn downwards and sink. And eventually those slabs get too heavy and break off, plunging slowly toward the core and creating a suction force that pulls mantle material along behind them. So in some ways, seafloor crust is really more like part of the conveyor belt than something riding on top of it. The continents, on the other hand, are baggage.
Okay, let's go ahead and move on to the next one. All right, so on this one, you have 4 spheres of the Earth. Here is your chart that you need to be working on. So if you want, you could be on this chart while I am talking about the other slide to kind of help you out. When you are on this side, how are you going to remember it? You could do a hashtag, or you could like draw a little symbol or something that's going to be quick, or you could draw a symbol that will help you kind of remember all of these things. Guys, this is the portion that you should be, really having full ideas. This should be really quick and easy. If you are going to, what I do not really want you to do is for you to insert a picture off of the web. Okay, that's like 2 more extra steps. Just do a hashtag if that makes it easier. Or, if you really are a visual learner, then go ahead and do that. But, I just kind of think writing it out might be easier and faster for you. There really has to be a quicker way to do this. And then there's a lag, so that's why it doesn't get it all. All right, so I'm going to go to this one. So when we're looking at this one, we have the atmosphere, and the atmosphere is going to be A for air. So we have a lot of air up here. This is where you're going to get your oxygen, your carbon dioxide. Okay, so there's lots of different air particles that are in the atmosphere just floating around. We need it so we can breathe. An astronaut is going to get into his spaceship and is going to go past the atmosphere to reach outer space. In science, they're going to tell you that there's other layers next to the atmosphere. You don't need to know that for geography. We're only going to be focusing on just the atmosphere itself. Now, let's go ahead and talk about the lithosphere. The lithosphere is going to be the crust, okay? So if we are looking at a pizza, if the Earth was a pizza, it would be the crust part. This could be 3 miles long, or it could be 50 miles long. Oh, don't do that. Or it could be 50 miles long, depending on where you are located. So if it's on a mountain, it might be closer to the 50 miles. If you are in the bottom of the sea, it might be closer to 3 miles, okay? The lithosphere is where you're going to have to dig. So notice how like right here, there's a pond or a lake. It doesn't exist until underneath that, okay? So it's the crust. Either you are under the earth or you are standing above it. And this water is just standing above the earth, okay? That leads us to our next one. Let's go ahead and talk about biosphere. You are taking a science right now this school year, and it is called biology because bio means life, okay? So anything that is living, anything that is breathing is going to be, part of the biosphere. So us, we are humans, we are alive, so we are part of the biosphere. An octopus living in the water is alive and is part of the biosphere. A worm digging in the lithosphere is part of the biosphere. Anything living is part of the biosphere, okay? That's one thing that a lot of students got wrong on the test last year. They kept wanting to say that the worm living in the crust, that it was part of the lithosphere, but that is wrong. So anything that is alive is part of the biosphere. Our last one is going to be hydrosphere. So the hydrosphere is going to be made out of water, and it's going to be any body of water. So it's going to be rivers, it's going to be lakes, a bay, a gulf, an ocean, okay? So anything that is water, that is what it's going to kind of fall under. It's going to fall under the hydrosphere. I don't think a cup of water would count as a hydrosphere, but if you really want to know, I would have to go and ask someone. Okay, so not to be kind of changing it up like the biosphere. Biosphere, an astronaut in the atmosphere is part of the biosphere. A worm in the lithosphere is part of the biosphere. A squid, the kraken in the hydrosphere, is going to be part of the biosphere. So anything living and breathing. Or the hydrosphere, remember, hydro is water. So when I tell you, or when your coach says, you got hydrate, yo, then he's telling you make sure you drink your water, because hydro means water. All right. So hopefully that helps you enough that you are able to write something into the next portion. You might want to pause it right now and fill out the what can you remember. I had a student who used hashtags, and that was just easier for them to use. So whatever it is, as long as it is school appropriate, then you are able to use it. But I do want to, again, remind you that your item that is going to help you remember should not be super long, okay? It needs to be short. It needs to be like a quick trigger your memory kind of thing. So this should be longer than your trigger to remember it. Let's go ahead and go to the next one. On this one, you have a lot of landforms, and what's going to happen on Friday is I am going to give you a mountain, and I'm going to tell you, here's a mountain. Now you have to explain to me, how was it formed? And your tectonic plates are going to be colliding together, okay? So that's what we're really going to be focusing on tomorrow. So right now, what I need you to do is to be able to identify all of it, okay? So what you are going to do on your presentation is right here, you are going to just kind of write down what you see and kind of describe it, because I need to be able to, on Friday, to like show you a picture of an island. It won't be exactly this picture, but I need you to know that that is an island. I'm going to show you a valley. A valley is going to be one that I highly recommend you do a good job on. The plains, I highly recommend you doing a good job on. Volcanoes and mountains. And the other one that students were constantly getting wrong last year was peninsula, which peninsulas are my favorite because that's just such a weird word. So as I've already given you the answers to what they look like, all what you are doing is going to describe it here, okay? And then once you are done with that, you have this last question that you need to work on. This question is asking you, why would knowing the layers of the earth in landforms be important in a geography class? Take a wild guess what geography means. Explain fully using complete thoughts. So make sure that this is just another example, like how on your test, what you write needs to convince me that you know what you're supposed to know. Okay. So we've talked about everything. I feel kind of good about this. I hope this helps you. Hope it helps. Bye, guys.